Hello everyone. Today I will be presenting my project on short-term solar and wind power forecasting using random forest and artificial neural networks. This is aimed at improving microgrid operation, especially in remote areas. Here is the outline of my project. I will begin with the motivation behind this work, followed by the project objectives, data processing steps, methodology for random forest and ANN, results from both models and comparison with existing literature, and finally the conclusion and the future development ideas. So what's the motivation behind this project? Why forecast renewable power? Because sources like wind and solar are intermittent and weather dependent. This variability can be challenge for remote microgrids which require a consistent and reliable power supply. Accurate forecasting allows me to reduce reliance on fossil fuel backups, optimize energy scheduling, and support the shift to sustainable energy system. So my project aim to develop short-term hourly forecast for both solar and wind energy. I am using machine learning techniques, especially random forest and ANN, to optimize energy distribution within hybrid microgrids. My goal is to reduce diesel generator usage, improve grid stability, and increase renewable energy penetration in isolated area. Data pre-processing was crucial. I handled missing values and outliers, used interpolation, and converted the data into a modeling frequent friendly format. I also scaled the features to ensure uniform contribution to the models. The data was decomposed into trend, seasonal, and residual components, and finally split into training and testing dataset. Methodology. Both random forest and ENN were trained on clean and pre-processed dataset. For random forest, I split data into training, testing, and validation sets and used metrics like MAE, RMSE, and MAPE to evaluate accuracy. ANN involved selecting appropriate architecture and iterating through training, testing, and deployment phases and refining the model as needed. First is random forest. The random forest model is an ensemble of decision tree trained on bootstrap data samples. It uses out-of-bag validation to estimate errors. This model is robust, handles high-dimensional data well, and offers feature-importance insights. It's suitable for both regression and classification, making it ideal for my forecasting task. ENN, the Artificial Neural Network Model. In the ENN model, after data pre-processing, I selected a suitable network architecture. Each neuron processes inputs using an activation function, includes a bias term, and generates output based on weighted sums. The goal was to find a model that balances accuracy and generalization, ready for real-world forecasting. The Bayesian model uses layers including sigmoid and tanh activations. The input layer passes data through neurons which adjust weights based on learning. The layers extract patterns and help the model predict output values efficiently, formatting the basis of my time series forecasting. Results. This graph shows the performance of random forest model during peak hours and across the full day. As we can see that the predicted values closely follow the actual power generation pattern, especially during the high output periods, indicating the model's reliability for short-term forecasting. Here I compared ANN result using data sets of different sizes, one using 4 years of data and another using just 1 year. The model trained with more data shows a smoother and more accurate prediction curve, highlighting the importance of long-term historical data for training deep learning models. To validate my approach, I compared my results with published findings from other research papers. I plotted random forest and ANN outputs alongside the results from two different studies. As shown, random forest perform comparably and in some cases better than existing models, especially in matching peak outputs and maintaining smoothness. Here you can see that the actual power and my research is nearly similar and it is more accurate than the other research paper that has been done by someone else. Also, it shows that my method isn't just accurate on my dataset but also holds up when compared with established techniques in academic research. In summary, my project illustrates that machine learning, especially ANNK, can play a key role in renewable energy forecasting for microgrids. Accurate forecast enables smarter load scheduling, reduced fuel usage, and enhanced grid reliability, while random forest offers simplicity and speed. This makes it better suited for energy systems influenced by weather patterns. These insights can inform energy policy, guide real time operations, and support remote communities in achieving energy independence. Going forward, we see that I see several opportunities to improve this work. First, I can refine the random forest model by including time aware features like sine, cosine, hour encodings. Second, I aim to incorporate diesel generator dispatch logic into the forecasting framework. Third, I want to test other models such as GRUs and hybrid LSTM CNN models. Finally, I envision developing a real time dashboard to visualize and control forecasting for microgrids, potentially integrating with actual community based energy projects. If you have any question, I am open to feedback and discussion. Thank you all for your attention.